In section 9.3, we are adding and subtracting rational expressions. So these rational expressions, we're going to have fractions here. We know we're going to have x in the denominator most of these times, and then we're just going to be adding and subtracting them. So this is very similar when you just add and subtract fractions that we've learned, since elementary school. When you do this, again, you can only add or subtract fractions if they have the same denominator. So for example, problem number 1, we have 7/20 plus 3/20. Because we have a common denominator, we can add these together, and this would equal 10/20. Now 10/20 can be reduced, right? I know that I can divide the top and the bottom by 10, right? Now again, the reason why this works is because I'm dividing by this is equal to 1. So I can divide anything by 1 and it retains its value. So I'm not changing the value of this expression, I'm just kind of changing it how it appears, right? If I eat a pizza that has 20 slices, instead of eating 10 out of 20 slices, that'd be the same thing as eating 1 out of 2 slices, or 1/2. All right, so remember, you always want to reduce those fractions if possible. Question number 2, we do not have common denominators, so I cannot add these as they are. But again, that rule is I can multiply any fraction by something equivalent to 1. So I can't just go ahead and multiply the top by 6 and just be like, oh, these 6's cancel out. You cannot do that because multiplying by 6 would make this 6 times as large, and you can't just change a number into something else, all right? Unless you have an equation, of course. So in this case, I have to, again, multiply by some value that's equal to 1. And if I want to get the common denominator, I can see that the LCD here would be 24, right? 8 times 3 is 24, and 6 times 4 is 24. So I want to get both of these to be 24. That means that I'm going to multiply the fraction on the left by 4/4 and the fraction on the right by 3/3. All right? What this gives me is 20/24 plus 3/24. And because I have common denominators, I can now go ahead and add these together. And we add these and we get 23/24. Right? That is not reducible, so that would be your answer. Okay. Again, the really easy way to think about this when you're adding fractions, imagine if I had, let's say 1 cat plus 3 cats equals 4 cats, right? It doesn't become 4 dogs or 4 cats squared, right? We don't multiply those together either. It stays the same. So when I'm adding fractions with like denominators, stays the same. Again, over here, stays the same. So don't be tempted to do 24 plus 24 is 48 here. That would not be correct. Make sure you keep that denominator the same. We typically kind of like to think of them as maybe units, right? Like I could use like a number, for example, like 20 billion plus 3 billion is 23 billion, right? Kind of think of them as units there, all right? So whenever you add and subtract the numerators, keep the denominators the same, all right? Again, like we said, we have to have the same denominator. As we see here, I have an x minus 4 in both of the denominators, so therefore I can go ahead and add these together. And we said that when we add fractions, we have to keep the denominator the same, so still x minus 4. And then I'm going to add the numerators together, and 3 plus -1 is equal to 2. We still have an x in front, so that's just x plus 2. And we get x plus 2 over x minus 4. Tempting to want to cancel these out, but you cannot. Tempting to want to cancel these, but you cannot either. Remember, this expression in the numerator, for example, let's just say x was 3, all right? So let's say x is equal to 3. If I plug in a 3 for x, that would give me 3 plus 2 is 5, and 3 minus 4 is -1. So this would equal -5, all right? If I plugged in a 3, this would be -5. Well, let's say we went ahead and we canceled out the x's, right? So if I got rid of these x's, that would be -1/2. But we know that -1/2 is not the same as -5, so that can't be true. That would not make sense to cancel those out. Same idea, if I reduced these to 1/2, well, x plus 1 is 4 if I make x equals 3. And if x is 3 minus 2, well, 3 minus 2 is 1. 4/1 is 4, and again, that's not the same as -5. So it just goes to show you that there's no way you can cancel these, reduce these or cancel these. That would not be logical, all right? So we know that we cannot have any sort of cancellation. We are done. Nothing factors, nothing reduces. That would be our final answer. Question number 2, we're going to try something similar. Again, we see that we have the same denominators here, so that means I can go ahead and subtract. Now, when I subtract, you have to be careful because you are subtracting all of that numerator, all right? So in other words, this negative applies to the x and the negative applies to the -5. All right, so you got to be very aware of that. Don't forget that. So we're going to keep the x squared minus 4 in the denominator. And if we have 2x minus x, well, 2 minus 1 is just 1, so we have a 1x here. And then if I have -3 minus -5, that's really the same as -3 plus 5. And we know that -3 plus 5 is +2. All right, so we got x plus 2. So we might say to ourselves, oh, I can't cancel the x's, oh, I can't cancel the 2 and the 4, which is true. You cannot cancel those. However, if I look at this denominator, I see that this is factorable. So what we really have, this is a difference of squares. That's really a x plus 2 times x minus 2. In the numerator, I have an x plus 2. So now when I look, again, I can cancel anything when I have the exact same thing in the numerator and the denominator. And so because I have an x plus 2 in the numerator and I have an x plus 2 in the denominator, these will cancel with each other. All right, and so that gives us 1 over x minus 2, and that would be our final answer. So you do just have to be careful. If there's anything that you can factor, you always want to make sure you can factor. All right, so I'll put a little note here. Factor if possible. All right, this would not be a final answer. That's not correct. You need to go one step further. All right, when rational expressions do not have common denominators, you first want to identify the LCD. All right, so the LCD, if I look at this, again, I'm trying to get this x plus 4 to be the same as this 2x plus 8. A great first step is to try factoring. All right, and just try factoring the denominators. All right, this is usually going to give you some good clues as to, making your life a little bit easier. So if I look at the first fraction, that's 7x minus 6, I could factor out a 2, leaving me with x plus 4. And the second fraction, I can't really do anything with that. There's nothing that I can factor with the x plus 4. However, when I look, I see that both of the denominators have an x plus 4 in common, which is great, right? I want the same denominator. So if they both have an x plus 4, the only thing that I need over here is a 2, right? I want to try to match the 2's. But I can't just add a 2 in the denominator unless I also add a 2 in the numerator, right? I have to multiply by a fraction that's equal to 1. And that's what this statement says here, right? You're going to multiply one or both terms by a fraction equivalent to 1. And in this case, we only have to multiply one of them, but we multiplied by, again, this fraction is equal to 1. So I'm not changing the value. I'm changing how it looks, but we're not changing the value at all. All right? So this is going to be helpful because now it's going to allow us to combine all these terms into one. So at this point here, we're going to go ahead and look at what we got. And if we do this, we've got 7x minus 6 over 2 times the quantity x plus 4. Then we've got a plus. Now this 2 gets distributed to everything in the numerator. So this gives me 2x squared plus 36. And this is all over 2. That 2 also gets distributed to the x plus 4, right? But I'm not going to do that distributing just yet. The reason why is because if I distribute, we're going to see at the end that there might be something I can cancel out. Sometimes you can, sometimes you can't. Just depends on the problem. So if we were to distribute all that, that would kind of take away the obviousness of any canceling that happens at the end. So now I'm going to go ahead and combine the numerators. We see that we have a 2x squared. That's my only x squared term in the numerator. The 7x is the only term with x in the numerator. And then negative 6 plus 36 is equal to 30. All right, and that's all over 2 times x plus 4. All right, and now the numerator, again, I always want to just test to see if I can maybe factor this, right? Because if I factor this, and let's say I ended up with an x plus 4 on top, well, then I know the x plus 4 and this x plus 4 would cancel, right? So I want to always test to see if I could factor, because something might be able to cancel out. We're not quite sure yet. So if I look at these, this numerator, I can say, well, 2 times 30 is 60. So I'm looking for two numbers that multiply to be 60, but also add up to be 7. And so if I look at these two numbers, I'm kind of going through the list. We've got 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12. If it was negative, that might work out, but it's not negative, so we can't add those up to be 7. Let's see, we've got 6 and 10, and I think that's about it. So we actually cannot factor this numerator. All right, we could use quadratic formula if we wanted to solve it, but it's not going to be factorable, and we're not going to be able to cancel out any common terms there. So because we can't factor the numerator, this is our final answer. You might also see it written like this if you're taking the ACT or SAT, where it's all in expanded form. I'm okay with either answer. So if I just distribute that 2, we've got 2x plus 8. That would also work, and that could be a good answer. All right, so either of those would be fine. But again, you do want to check to make sure that you can factor this. On that Chapter 9 test, you will see some that do factor, and then once they factor, you'll be able to cancel some things out. So just be careful of those. And then let's try one last example here. We're going to subtract. And so again, I want to get common denominators. And right now, I do not have common denominators. So a good way to see if we can get common denominators is to maybe factor. And this first one is not factorable, so I'm going to leave that one the same. 2x minus 3 over x plus 5. But I want to see if there's a way to factor this denominator. All right. It looks like I'm looking for two numbers that multiply to be negative 35, but also add up to be negative 2. And I think those numbers are negative 7 and positive 5. All right, and that does seem to check out. So we've got a 5 plus 2x squared here over x minus 7, x plus 5. And so now if I look at my denominators, well, this is great because we see that I have an x plus 5 in this denominator and an x plus 5 in that one. So all I need to get is another x minus 7, and I need to get that x minus 7 over here, right? So to get that x minus 7, I'm going to have to multiply the top and the bottom by the x minus 7. And this should help me out because now I'm going to have common denominators. And I will see that I have to do some foiling up here in the numerator. So if we FOIL, let's see what we get. We're going to get 2x squared. Negative 7 times 2 is negative 14x. And then if we also subtract 3x, that's negative 17x. And then negative 7 times negative 3 is 21. Don't forget your x squared there, whoops. And then in the denominator, I'm going to leave that split up. I'm going to leave that as x minus 7 times x plus 5. Again, we're not sure if anything's going to maybe factor in the end, so we're going to keep it split up for just now. X minus 7, x plus 5. And I still have the 5 plus 2x squared. So a reminder that this negative applies to both of these terms. So when I'm doing this next step here and looking at combining my numerators, I do have to make sure that this minus gets distributed. So at this point, we're going to have a 2x squared minus 17x. And actually, let's just combine these terms right now while we're at it. If I take 2x squared minus 2x squared, that's just 0x squared. So there's no more x squareds. All right, so that makes it a little bit easier. If I look at my x's, we've got a negative 17x, and then there's no more x's in the numerator. So I know I have a minus 17x in the numerator. Then I have 21 minus 5, and 21 minus 5 is 16. So we've got a 16 in the numerator. In the denominator, we've still got x minus 7 and x plus 5. And if I look in the numerator, there's no way I can factor this numerator. So because it's not factorable, there's nothing else I can do. All right, I can't cancel anything out, can't move anything around, so this is going to be your final answer. All right, again, another possibility is to FOIL the denominator. All right, and if we did that, we'd end up with what we originally had, x squared minus 2x minus 35. All right, I'm okay if you leave it as either of these. Again, this second one is maybe more likely for a standardized test that you'd see this, just to kind of not trick you, but get you to think about foiling in the end as well. So something to think about. But again, make sure you try to factor this numerator if possible, because it always could be the case where you do factor it and then something in the denominator cancels with something in the numerator. Okay, we kind of saw that example happen up here with this case, right? So again, if you factor and things cancel, make sure you cancel them out. All right, so always check for that.